We're going to be looking today at simplifying algebraic fractions, and that's going to be when we're adding or subtracting them. Last lesson, we talked about multiplying and dividing. And, when we're doing this with algebra, it's very similar to what we actually did just with regular old fractions without pronumerals. So last lesson, we did multiplication and division. And if you had something like 2 over 3 times, 6 over 8, you could think about doing the cross method. So you could cancel things down using that. And that would mean that you could do like 2 goes into 2 once, and it goes into 8 4 times, 3 goes into 3 once, and it goes into 6 twice. So then you end up with, and we could also go 2 goes into 2 once and 4 twice. But basically, we were thinking about cancelling stuff down. When we had division, we remembered that that was very similar to when we multiplied fractions. It just meant we flipped the second fraction and multiplied. Now, the other thing we also spoke about when we did multiplication and division is we always thought about factorizing first. That was really important because that meant that we could cancel off if we had something like, x minus 2 over 3a times, I'm making this up, b squared over x minus 2, or maybe it was like something like 4x minus 2, we could cancel off entire brackets there. So that's really thinking about multiplying and dividing. Just like in regular old fractions, just with numbers, addition and subtraction is a little bit different. For example, if you had 2 over 7 plus 4 over 7, you're not thinking about bow tying or cancelling down or anything like that. You're now thinking about your denominators because you need a common denominator to be able to add or subtract fractions. So, got a nice common denominator there, and we're going to have it over 7, and then you just add the numerators, 2 plus 4. So we'd get 6 over 7 for that. When we're thinking about things with different denominators though, let's just say we had something like, then we started thinking about the lowest common denominator, and that's the lowest common multiple for each of these numbers. Now hopefully you can see that the lowest common multiple would be 21, because 7 times 3 is 21, and 21 just times 1 is 21. I like to write it with a big vinculum and the 21, because that means I can just scoop up whatever my numerators are going to be and put them just on top of that big vinculum. Now to have that as the common denominator, recall we need to multiply the top and bottom of this fraction by 3. Whatever you do to the denominator, you must also do to the numerator. So it'll give you 6 plus 5, which would give you 11 over 21. What we're going to be doing in algebra is very, very similar to that. Just thinking, am I multiplying and dividing, or am I adding and subtracting? And with these examples here, we're adding and subtracting. So like we discussed, we need to find the lowest common denominator. Sorry, that bracket wasn't finished. We need to express each part over that lowest common denominator, and then we're going to collect like terms across the numerator. At the top of your page, but also we're going to write it here, we're going to need brackets. They're going to be critical for some questions later on, similar to some other times in algebra where we've desperately needed brackets to make sure we're doing things correctly. Okay, so we have our first algebraic fraction here that we're adding. We have x over 2 plus x over 3. Before we get into it, what's going to be the lowest common denominator? Hopefully you can see that's going to be 6. So we need to multiply the top and the bottom of the first fraction by 3. And we also need to multiply the top and bottom of the second fraction by 2 to achieve that lowest common denominator of 6. Make sure you draw a big old vinculum. Let's try and make it horizontal. So we can put all of our numerators on top. Just saves a bit of time. It means you're not writing a separate over 6, and you're probably less likely to make an error with it. Trust me on this one. Okay, so what is x times 3? Well, that's going to be 3x. Now, this plus sign is what's going to come down here because we were adding these two fractions together. And then we've got x times 2, which is 2x. Really good. Now, we mentioned that we might have to collect like terms across the numerator. I notice we've got 3x and 2x here, so they can get put together to make 5x. over 6. Let's have a look at subtraction. Very similar, except it's subtracting. What's the lowest common denominator of this one going to be? I notice we've got a 4 and a 5, so our lowest common denominator is going to be 20. To achieve this, this needs to be multiplied by 5, so the top also needs to have the same treatment. To achieve that as well, on the second fraction, we'd need to multiply the top and bottom by 4. So let's draw a big old vinculum, I already had it, and our common denominator of 20, lowest common denominator. Now we've got to do 3x times 5, that's going to be 15x. And what were we doing? What operation? It was subtraction. So let's take that down. And then we've got 2x times 4 will be 8x. Not too bad. So we've now got 15x and we're taking away 8x, and that's going to give us 7x over 20. Okay, our next one, we have 2x and we're subtracting 7x over 4. Now, hopefully you recall, but if not, I'm going to show you, we could write anything over 1. Now that we have those two fractions, let's multiply the top and bottom of this by 4, because that's going to be our lowest common denominator. And with this fraction here, it's already 4, so we don't need to do anything to that second fraction to make it have that denominator that we want. So big old vinculum, and our common denominator of 4. So 2x times 4 will be 8x. We're subtracting here, so we bring down that subtraction, minus 7x. So remember, we could write that as x over 4. We've got an invisible coefficient of 1 here, but, we're a little bit lazy. We can't be bothered writing that. And it looks nicer without it, in my opinion. Okay, last one. I want you to have this a go by yourselves and see if you get the same thing I do. The thing about these trickier examples is the game plan is the same. We still want to end up with the lowest common denominator here. That's what we really want to achieve. However, to achieve that, we're going to need a friend, and I'll show you what that involves in a moment. Looking at the denominators of this example, A, we've got 6 and 4. The lowest common denominator here is going to be 12, not 24. We want the lowest one possible, because 6 times 2 is 12 and 4 times 3 is 12. So we need to multiply the bottom of this one times 2 and the bottom of this one times 3. Whatever we do to the top, we must also do to the bottom. But we've got a bit of an issue. Which term am I multiplying by 2? Do I put the times 2 here and it just multiply with the 1? Or do I put the times 2 here and just multiply with the x? Hopefully you realize we don't want to choose. We want to multiply this whole numerator by 2. To do that, we could put brackets around this. And then putting a 2 in front of the bracket tells us the x is multiplied by 2 and that positive 1 is multiplied by 2. Brackets are our friend. So don't forget your brackets here. Now with the next one, we're multiplying everything on top by 3, and brackets is how we group things together. So we're going to put a 3 in front of that brackets because we multiplied the denominator of this fraction by 3. Don't skip steps with this, everyone. Really work on doing the steps that I'm demonstrating here because you're less likely to make mistakes. So now what we've got is 2, and then in brackets x plus 1, plus 3 in brackets x plus 4. And just in case you're wondering, you're more than welcome, if you're given a question on a test or on a worksheet, to annotate the question exactly as I've shown here. This is wonderful working out and it shows your thinking. You don't need to rewrite the question and then start annotating it. Be as efficient as you can. Oh, we now have, it looks like, some single bracket expansion. That is delightful. So let's expand that out. We've got here 2 times x and 2 times positive 1. Now with the second bracket, we've done expansion like this before. Remember that this positive sign, when we're expanding that bracket, belongs to that 3. So we've got positive 3 times x, so plus 3x, and then positive 3 times 4, so plus 12. Denominator of 12. Now we go about collecting like terms. So this is our final answer. Let's have a go at the next one. It's a little similar. So looking at what we've got here, what would be the lowest common denominator that we're aiming for? That would be 10. So to do that, the first fraction's fine. It's already got that numerator of 10, so we don't need to worry about that. But this second fraction though, we need to multiply the bottom by 2 to achieve that 10, and that means we need to multiply the top by 2. We've got more than one thing in the top, so let's put brackets around that and a 2 out the front. So, now what do we have? That first thing, y plus 1, remember that the numerator's like it's its own set of brackets here. So you could put it in brackets y plus 1, but we didn't really need brackets here. You might be wondering why on earth I mentioned that. You'll see with an example later on. That's going to be pretty important. But here, the brackets didn't achieve anything. Now, in the second part, we've got plus, because that plus sign was there, 2 in brackets x plus y. So we need to expand out this second bracket. That's a positive. Oh, now before we get into things, just to be clear, you might notice there's a y plus 1 here. You can't then go 1 plus 2. No, because that's not with the laws of BIDMAS. And some people like to imagine that they can't do that yet because those invisible brackets are there. But that's not my preferred way of thinking about it. I just like to remind myself I don't want to be tempted to do 1 plus 2. I'm going to expand the bracket first because of BIDMAS. So BIDMAS means we need to expand this first. So the y plus 1 is just going to hang out there because that's much lower down the chain of BIDMAS. It's addition. And then we've got the plus 2x plus 2y over 10. Okay, so looking at like terms here, I notice we've got a y and a plus 2y. So let's put that together, 3y plus 1 plus 2x. You could have written that in any different order. You could have had 2x plus 3y plus 1, 2x plus 1 plus 3y, so long as, you're just careful with it. And that's our final answer. Let's now look at some examples that involve subtraction of algebraic fractions. First off, lowest common denominator. We're adding and subtracting fractions. We've got 6 and 4, and we previously realised that would have a lowest common denominator of 12. So to achieve that, the denominator of the first one needs to be multiplied by 2. So that must mean the entire numerator needs to be multiplied by 2. Now, with the second one, we need to multiply this denominator by 3. So that must mean the entire numerator is multiplied by 3. Something to also keep in mind. We have a negative sign there. So we need to make sure that we put a negative sign on our numerator when we've combined our fractions, because it's a subtraction. 2x plus 2 in brackets, and then we're going to have that minus that we spoke about, and then we've got 3 bracket x minus 3. Pretty lucky that we've practiced our single bracket expansion, because that's going to be really important for this. So let's expand this first one. Now, remember, this 3 owns that negative sign. Really important here. So when we expand this one out, it's negative 3 times x to be minus 3x, and negative 3 times negative 3, which will be positive 9. If you're not careful, you're going to make a sign error with that last term. Just do it slowly. Do it exactly as I'm laying it out here. You can highlight, you can draw arrows. Think the steps through as you're doing them. Try not to rush. Now that we've done that, we can collect like terms. Let's be careful with our negatives here, because we've got 2x minus 3x. That's going to give us minus x. And then we've got, with our numbers, 4 plus 9, that's going to give us 13 over 12. We've talked about this a little bit, but that could have also been written as 13 minus x over 12, because the x in both cases is negative, the 13 in both cases was positive, and they've got the same denominator. You will make errors with the next kind of question if you don't practice this really carefully and listen really carefully. It's tricky, but let's go through it together. I notice that we've already got a common denominator. Oh, that's going to make our lives so much easier. So let's write equals, and we're just going to do 3. Now, we're going to put the numerators on this, and I'm going to make a mistake. Don't worry, I'll tell you what it is, but I want you to think about it. So we've got x plus 7 minus x minus 3. Now, you might be looking at that going, wait, I thought you were going to make a mistake. Or maybe you're sitting there going, oh, I see what that mistake was. This is critical. This negative sign, that doesn't just apply to the x. What we're saying here is we want to take away the entire thing here. We want to take away all of x minus 3. Now, the problem is how we've written it down here. That negative sign impacted the x, but it didn't impact the 3. So how are we going to be able to make it so that negative sign also impacts that negative 3? What we're going to do is our really, really handy friend here, brackets. So brackets are essential. Sorry, I realized I fell off the screen. So brackets are essential here. That negative does not just interact with the x, it must also interact with that minus 3 on the end. So that means we're going to have just x plus 7 hanging out here. And what's going to happen with that second bracket? Well, it's like there's an invisible negative 1 that needs to be expanded out in this bracket. Now remember, multiplying something by negative 1 just changes the sign. So that means it would be minus x, and we'd have plus 3, because negative 1 times negative 3 is plus 3. This plus 3 is like super duper important. Having changed the sign of that negative 3 to a plus 3 completely changes the problem to the correct answer. Not having that plus 3 means it's incorrect. So really think, brackets are your friend. That negative sign has to interact with the entire numerator here. Now that we've accomplished that, we're going to collect like terms. Ooh, this is nice. I'm not sure whether you've noticed, we've got x minus x, so that just goes away. And then we've got 7 plus 3, that's just going to be 10 over 3. Improper fractions are perfectly fine. I've got no problem with them at all. So far, we've realised that adding and subtracting fractions that are algebraic is very similar to when we just had numbers. Except, sometimes with algebra, we've got more than one term on top of a fraction. And to make sure that's dealt with correctly, brackets are essential. They help us make sure we're grouping things together. Okay, let's have a go at the next 2 examples. They're very similar to the past things that we did. We're just thinking common denominator. Then we're thinking, what do we need to multiply by? And then we're thinking bracket friends. And this one I notice has a negative sign, so we need a negative here. So let's go and do it. We've got 2, and then in brackets 3x plus 2, minus 3 in brackets x plus 4. Now we'll expand. (6x minus 3x) are our set of like terms here. Remember, don't forget that sign in front. So we're going to have 3x, and then 4 minus 12 is going to be negative, and then think 12 minus 4, well that's going to be 8, so 4 minus 12 will be negative 8 over 12. Remember, we can't cancel down anything with that 8 and that 12 now, because we don't have things separated by multiplied signs. Okay, next one. Our lowest common denominator is going to be 4, because we need to multiply this by 2, and this fraction's already ready to go. So we need to multiply everything on the top by 2. So we're going to have 2, and then in brackets 3x plus 3. We've got that negative sign here. So that means the entire top of this is being subtracted. So when we put that negative down there, we need to put a set of brackets around the 2x plus 1. Remember, that means that that negative sign also interacts with this plus 1 at the end. Expanding that first bracket, this is like an invisible -1 here that's multiplying out. And multiplying by -1 just changes the sign. So minus 2x minus 2. Oops. -1 times +1 is -1. Whoopsie. Times 4. Okay, like terms. We've got 6x minus 2x. That's going to be 4x. And then we've got 6 minus 1 plus 5 over 4. Can't do any more cancelling. That's our final answer. The last tricky bit we're going to do involves having some pronumerals in our denominators. I want you to have a think. If we've got a denominator of x and a denominator of 2x, what do you think our lowest common denominator is going to be? You might realise that multiplying the top and bottom of the first fraction by 2 works. Because on the bottom, I would then have a denominator of 2x. So if we did times 2, we'd also need to do times 2 to the top. So our lowest common denominator we said was 2x. And then looking at our numerators now, we've got 2 times 1 would be 2. We've got that negative sign here, minus, and then we've got 3. We didn't have to do anything to that second fraction because it already had our lowest common denominator, which we mentioned here. 2 minus 3 is going to be -1 over 2x. And just so you know, that could also be written as just a negative out the front, 1 over 2x. The reason being a negative divided by a positive gives our overall answer being negative. We now have a question where our denominators are 3y and 5y. I wonder what you think the lowest common denominator is going to be in this example. What can we do to be able to have, when we do our question later on, a nice common denominator? If we've got 3y and 5y, I think our lowest common denominator is going to be 15y. That would be because we'd multiply the bottom by 3 and the top by 3 for that second fraction. And then on the first fraction, we'd need to multiply that by 5. And then whenever we do the denominator, we have to do the numerator. So it looks like we're going to have 5 times 2x, which will be 10x. And then plus, that plus sign's there. 3 times 3 is 9. And then on 15y. And that's our final answer. The trickiest bit is identifying that lowest common denominator. But if you can kind of see what worked there, that is brilliant. If you're not sure, talk to someone else in class, or I'll talk to you when I get back next lesson. Have a great day, everyone.